Welcome. There is nothing you must do now and nowhere you need to be. Let your body grow heavy, let your breath lengthen, and let the room soften and dim around you. Tonight we drift along the river of time itself into the real and gentle science of time travel. This is the Circadian Institute, where each night we wander somewhere vast or strange, and let the slow wonders of science carry a tired mind toward sleep. Tonight we explore how time bends, stretches, and flows. If this voice helps you rest, subscribing keeps these long, calm nights coming. Nothing here needs remembering, and there will be no test when morning comes. The story of time is deep, yet depth, told slowly, becomes a kind of comfort, and comfort is a fine doorway into sleep. You need only listen and let the current carry you. Picture a river that has carried you since the moment you were born. It moves at a steady pace, always forward, never pausing, never turning back. We call it time, and tonight we will follow it together gently toward some of the strangest and most beautiful ideas in all of physics. For as long as there have been people, we have felt this current. It bears us from one breath to the next, from morning into evening, from who we were toward who we will become. No one has ever managed to hold it in place, even for a single heartbeat. That is the curious thing about this river. You cannot wade upstream against it, nor can you rest on its bank and let it pass you by. It simply carries you onward and onward at a rate that never wavers and never asks your permission. And so, across every age and every land, people have shared one quiet dream. They have longed to move through time the way we move through a meadow, freely, choosing our own direction, lingering where we wish and returning to what we have loved. That dream is where our story begins. Tonight we will ask what time truly is and whether this river might be navigated after all. Let the question settle over you like dusk, and let your breathing fall into its slow and easy rhythm. Think for a moment about the space around you. A room has length, the distance from one wall to another. It has width, the span from side to side, and it has height, the reach from the floor up toward the ceiling above your resting head. These are the three dimensions of space, the three directions in which anything can move, left or right, forward or back, up or down. Every place you have ever stood can be described by these three simple measures, and nothing more is needed to find it. Physics asks us to add one more direction to that list. Not a fourth way through space, but something else entirely. It asks us to treat time itself as a dimension, woven together with length and width and height into a single, seamless whole. This combined thing has a name. It is called space-time, a fabric of four dimensions in which every event has both a place and a moment. The idea was given to us by the mathematician Hermann Minkowski, who described it in the year 1908. It can feel strange to imagine time as a kind of direction, yet the notion is one of the deepest in modern science. Hold it loosely the way you might hold a smooth stone, and let it rest in your mind without effort. Here is a thought that may surprise you as you lie there in the stillness. You are, at this very moment, a time traveler, not in some far-off future, not in a machine of gears and light, but right now exactly as you are. Every one of us is moving through time without trying. We travel into the future steadily, ceaselessly carried forward by that same unhurried river. From this breath to the next, we are always arriving somewhere we have never been before. The pace of this journey is wonderfully simple. We move into the future at a rate of 1 second per second, the most natural speed imaginable. For each second that passes, we ourselves advance exactly 1 second onward into what is to come. And nothing we do can halt it. We cannot slow this advance by wishing, nor hurry it by hoping, nor step off the path to wait beside it. The future arrives for all of us at the same gentle, unstoppable rate. So you need not seek out time travel as some distant marvel. You are already doing it this instant with every quiet beat of your heart. The only question left is whether the journey could ever be anything other than this. If we are all moving into the future at one steady pace, a deeper question begins to stir. Could we ever change that pace? Could we somehow move faster into what lies ahead, reaching tomorrow while others are still living today? And then comes the bolder wondering, the one that has fascinated storytellers for ages. Could we ever turn around entirely? Could we journey not forward but back, returning to a moment already gone, to a day we thought was lost forever? These two questions sit at the heart of our story tonight. One looks ahead toward a future we might reach more swiftly. The other looks behind toward a past we might somehow revisit. Together they shape everything that follows. It helps to keep them separate in your mind, for they are not the same. Moving faster into the future is one kind of voyage. Returning to the past is another thing altogether, far stranger and harder to imagine. Let these wonderings drift through you like clouds across a darkening sky. You need not answer them now. Simply hold the questions gently and let the warmth of curiosity carry you a little closer toward rest. The two journeys we have imagined turn out to be remarkably unlike each other. When physics examines them closely, they part ways completely. One road proves open and inviting, the other vanishes into a fog of riddles and doubt. Travel into the future, it turns out, is genuinely allowed. The laws of physics make room for it. There are real ways woven into the fabric of the universe by which one could leap ahead in time and arrive in a distant tomorrow. This is not fantasy or wishful thinking. It is a true possibility, written into the deep rules that govern stars and motion and light. To move faster into the future is something nature permits, strange as that may sound. The journey backward is a different matter entirely. Travel into the past is far stranger, riddled with puzzles that twist back on themselves. The more closely one looks, the more tangled and uncertain the whole idea becomes. It may even be that returning to the past is simply impossible, forbidden by something we do not yet fully grasp. Hold both roads in your thoughts, the open one and the shadowed one, as the night settles around you. Let us return for a while to the river as we know it, the ordinary flow of an ordinary day. This is the time we live inside, the current that moves through every kitchen and garden and street, unnoticed yet always there. It carries us from waking to sleeping and around again. It turns the morning light to noon, and noon to the long gold of evening, and evening at last to the deep hush of night where you now rest. We rarely feel ourselves moving through it, Just as a passenger asleep on a boat may not feel the water sliding past below, yet the motion is always happening, smooth and unbroken, beneath the surface of each passing hour. This everyday flow is where every great idea about time must begin. Before we can imagine bending the river, we must first know it as it is, this calm and faithful current that has never once let us down. Feel it now, if you like, as a kind of company in the darkness. The same time that moves the farthest galaxy moves through you as well, carrying you onward with the whole quiet universe for a companion. From this familiar current, our journey will carry us somewhere far less ordinary. We begin in the everyday flow that we all feel, and we follow it outward, step by gentle step, toward the most surprising ideas physics has ever dared to hold. Tonight we will follow time itself wherever it leads. We will move from the steady tick of the present moment toward shores where the rules begin to soften and bend, where the river behaves in ways no one would expect. These are the strangest ideas in all of physics, and yet they grow from the simplest beginning. They start with the very flow you are feeling right now, the same one second following another, and they reach toward something far more wondrous. We will travel slowly, in no hurry to arrive. Each idea will unfold in its own time, like a landscape revealed bend by bend as a boat rounds a quiet curve. You may let the journey carry you as it will. So settle deeper into the stillness now, and let the current take you. There is no destination you must reach tonight, only the gentle motion of following time toward its furthest and most beautiful possibilities. We have stood together at the edge of a remarkable river, the river of time that bears us all. We have seen that it flows one way, steadily forward, never pausing, and that we are forever moving along with it. We have learned that time is a dimension joined with space into a single fabric named space-time long ago by a thoughtful mathematician. And we have seen that you yourself are a traveler, advancing always at 1 second for every second. Two great questions now wait quietly ahead of us: whether we might move faster into the future which nature seems to allow, and whether we might return to the past which remains a deep and shadowy mystery. These wonders will keep until you are ready for them. They are not going anywhere, and neither tonight are you. For now it is enough simply to rest here at the riverside, listening to the water move. So let your thoughts grow slow and your breathing grow even, and let the river of time carry you the way it always has, onward into the gentle dark, one peaceful second after another, toward the soft shore of sleep. Let us pause here a moment, between one wonder and the next. There is no hurry to move on. Breathe out slowly and let the vastness settle around you like a warm and weightless dark. Above you, the stars keep their slow turning, asking nothing of you tonight. You may simply rest beneath them, a small still point under an immense and unhurried sky. Feel how easy it is to be carried, held by a current far larger than yourself. Let your thoughts loosen, and let the next part of the journey find you already at ease. For centuries, people imagined time as a single great clock, ticking the same for every soul beneath the stars. In 1905, a young thinker named Albert Einstein gently set that picture aside. His special theory of relativity overturned the old belief that time flows at one rate for everyone. Picture the world before that year, sleeping under one shared rhythm. Every pendulum, every heartbeat, every falling leaf was thought to obey the same steady beat. Time seemed a river flowing evenly past all things, indifferent and absolute, the same in every quiet corner of creation. Einstein looked at this comfortable idea and asked a simple question. What if the river does not flow the same for all of us? What if your time and another's time could part ways like two travelers taking different roads beneath the same wide sky? This was not a wild guess whispered into the night. It grew from careful thought about light and motion, about what we truly measure when we measure a moment. The answer reshaped our understanding of the universe, and it began with one elegant, surprising idea. So let your thoughts loosen as we begin. You need not solve anything tonight. Only wander with me through these ideas. Imagine setting down the old single clock, that faithful keeper of one time, and opening yourself to a stranger, more beautiful possibility waiting ahead. At the heart of Einstein's theory rests a single surprising anchor. The speed of light through empty space is the same for every observer, no matter how fast they happen to be moving. Light travels at about 300,000 kilometers each second, always for everyone. Let that number settle over you like starlight. 300,000 kilometers in a single second, a span that could circle our world many times before a breath is done. Yet its true wonder is not the speed itself, but how stubbornly it refuses to change. Think of how ordinary motion usually behaves. If you walk along a moving train, your speed and the train's speed simply add together for someone watching outside. Common sense expects light to play by the very same rule, gaining or losing as its source moves. But light declines to follow that familiar custom. Whether its source rushes toward you or away, whether you chase it or flee, the beam arrives at the same unchanging pace. This constancy is the cornerstone on which the whole strange edifice is built. Hold that thought as you rest. One thing in this shifting cosmos stays perfectly fixed, a steady value woven into the fabric of space. Everything else, as you will soon see, must silently rearrange itself around this one unbending truth of light. Here lies the puzzle that changed everything. If light keeps the same speed for a still watcher and for one racing past, how can both possibly agree? Something else must give way, and that something turns out to be time and space themselves. Speed is only distance divided by time, after all. For a measured speed to stay the same across observers in motion, the distances and the durations must shift to match. Space can stretch, time can dilate, the numbers bend so light may stay constant. And so Einstein reached his quiet, staggering conclusion. Time is not absolute. It is relative, woven together with space, shaped by how you move through the world. The steady river became a thing that curves and flexes, different for different travelers. Imagine time and space as a single soft fabric, pliable as cloth. Move through it gently and it stretches one way. Move swiftly and it stretches another. The fabric adjusts itself so that the speed of light is forever preserved within its folds. Breathe slowly with this idea before we go on. The ground beneath the old clock has turned to something supple and alive. Time bends, space yields, and yet the cosmos holds together, balanced with a grace that has filled physicists with awe. One of the gentlest surprises of relativity is called the relativity of simultaneity. Two events that seem to happen at the very same instant for one observer may, for another, occur at quite different moments. The word now loses its single, settled meaning. Picture two distant lamps lighting up across a darkened plain. To you, standing midway, they flare together in one shared heartbeat of light. Yet to a traveler gliding past, one lamp may bloom before the other, their perfect agreement gradually undone. Neither of you is mistaken in what you see. Both observations are equally true, each correct within its own frame of motion. There is no master clock hanging above to declare which moment is the real one. Both nows are valid together. This dissolves a notion we rarely think to question. We assume the present is shared by all, a single slice of time wrapping the whole universe at once. Relativity reveals instead a cosmos with no universal moment, no one heartbeat for all. Let this strangeness rest lightly upon you now. Somewhere far away, an event you would call simultaneous with this breath might, for another, lie in the past or the future. The present is personal, tender, and gloriously yours alone tonight. Now we arrive at perhaps the most famous wonder of all. Moving clocks run slow. A clock in steady motion ticks more slowly than one at rest. As measured by the observer, it is moving past. This effect carries the name time dilation. Imagine a clock sailing smoothly by you through the night. To your eyes, its hands creep forward more sluggishly than your own, each second drawn out longer than it should be. Time aboard that traveling clock has loosened, stretched thin by its motion. This is no flaw in the mechanism, no fault of springs or gears. The slowing is woven into time itself, a direct consequence of light holding its constant speed. Any clock would do the same, for it is duration that stretches, not machinery. The dilation grows more pronounced. The faster the motion becomes, a slow stroll changes almost nothing you could ever notice. But approach the great speed of light, and the stretching of time swells until it can no longer be ignored. Rest with the strangeness of a clock that bends. The ticking you trust as constant is, in truth, a local thing, true only here, only for you. Elsewhere in swift motion, time keeps a different and slower beat beneath the same stars. Here is a thought to cradle as you grow drowsy. The faster you travel, the more your own time slows compared with those you leave behind. Your hours stretch gently outward, while theirs continue at the rhythm they have always known. Each of us, it seems, carries a private river of time. Yours flows with you wherever you go, and it answers only to your own motion through the world. No outside clock can overrule the steady, personal current that you alone possess. Imagine two friends parting, one resting while one journeys far. The traveler's seconds lengthen unnoticed by the traveler, who feels nothing amiss within. Only on comparing their clocks later would the gentle difference in their elapsed time finally appear. There is a tender beauty hidden in this truth. Time is not a wall imposed upon us from above. It bends with our movement, intimate as breath. Each path through space carries its own measure of hours, sketched by how we travel. So let your shoulders ease into the stillness here. The time that holds you now is wholly your own, unhurried, asking nothing, keeping pace with your slowing heart. Let it carry you softly toward sleep, your own river, your own gentle hours. Let us move toward the strangest frontier of all. As your speed climbs nearer to that of light, your time slows further and further against the world you have left. The closer you press to that limit, the more profoundly your own moments stretch. And at the speed of light itself, time would seem to stand entirely still. The hands would freeze, a single instant would open into forever. Motion at that ultimate pace would, in a sense, halt the very passage of time within. Yet this edge is a frontier no object can truly reach. Nothing with mass can ever quite attain the speed of light, however hard it strives. The limit beckons forever, a shore the swiftest traveler may approach but never finally touch. Light alone lives at that boundary, weightless and unbound. For a beam crossing the vast dark between the stars, the journey and its arrival might seem to fold into a single timeless point, a moment without duration at all. Let that immensity hold you lightly as you breathe. There exists a speed where time would rest, glimpsed only from afar, never quite entered by such as us. We live a little below it, where hours still flow and carry us onward. As this part of our journey draws to a close, let the wonder settle in. Einstein showed us a universe not ruled by one clock, but woven from countless times, each shaped by motion. The old single rhythm gave way to a richer music. Think of all the moving things scattered through the cosmos tonight. Stars, planets, drifting dust, and you upon your bed, each keeping a slightly different measure of the hours. No two need agree, and yet the whole stays bound by light. This is the quiet gift of relativity to a restful mind. Time is gentler and stranger than we ever supposed, not a stern overseer, but a companion that moves as we move. It bends toward us, personal and kind, never quite the same twice. You need not hold these ideas tightly any longer. Let them loosen and float, like stars wheeling slowly overhead, like a clock whose ticking has melted into the hush. The wonder has done its work. Now it asks only that you rest. So settle now beneath your own unhurried river of time. Let it carry you soft and certain toward the deep country of sleep. The universe keeps its many clocks without you. Yours may slow and ease, and finally come to stillness. Rest here again for a while. Time asks no questions and keeps no count of you tonight. Let the slow dark gather you in, soft and complete, and let the day's small weights fall away. Nothing in the cosmos is in any rush, and so neither are you. The great river of time moves gently beyond all measure, and tonight it carries your stillness along with it. Breathe in the quiet, breathe out the noise, and sink a little deeper into the warmth of your own rest. The journey will wait, calm and unhurried, until you are ready. Here is one of the strangest truths science has ever confirmed. The faster something moves, the more slowly its clock runs. This is not a riddle or a trick of words. It is measured again and again, woven deep into the fabric of how our universe keeps time. Let that knowledge rest easy on you. Time, which feels so steady and so sure, is not the same for everyone everywhere. Send a clock speeding past, and it falls a little behind one left at rest. The difference is real, even when it is far too small for us to feel. You might imagine time as a single river carrying us all at one pace. Relativity tells a softer, stranger story. Each moving thing follows its own current, its own rhythm of seconds. The swifter the journey, the more those seconds stretch and slow. We call this effect time dilation. It sounds like something distant, reserved for equations and laboratories, yet it is happening around you this very moment, in passing cars, in orbiting satellites, in the unseen rain of particles overhead. The universe keeps many clocks at once. So breathe, and let the wonder of it hold you. The cosmos does not insist on a single hour for all things. Motion bends the passage of time, ever so slightly, in ways we have learned to weigh and trust. Time itself is gentle and pliable. High above us, where the air grows thin, the sky is busy in ways we never see. Tiny particles called muons form there, born from collisions far overhead. They are fleeting things, fragile and short-lived, and they should vanish long before they ever reach the ground below. By all ordinary reckoning, a muon cannot last the journey. Its life is meant to be impossibly brief. It should decay high in the atmosphere, fading away miles above the fields and rooftops, and yet, against all expectation, a great many of them arrive. How do they survive a trip they have no time to finish? The answer lies in their speed. Muons race downward at nearly the speed of light, and at such velocity their internal clocks run slow. What seems an instant to them stretches longer for us. Picture that endless silent rain falling through the night. Each muon is a tiny traveler, its brief life lengthened by motion alone. Time itself grants them passage, slowing their inner clocks just enough to carry them home to the earth. This is no abstraction tucked away in theory. It is a direct, everyday confirmation of time dilation, written across the sky above your roof. Even now, as you rest, these gentle visitors arrive, proof that moving fast can truly slow the ticking of a clock. In 1971, a quiet experiment set out to test a remarkable idea. Researchers took atomic clocks, the most precise timekeepers ever built, and carried them aboard aeroplanes. Their plan was simple and bold. They would fly these clocks around the world and see what time itself had done. This became known as the Hafele-Keating experiment. Atomic clocks measure seconds with breathtaking exactness, far beyond anything our senses could detect. By sending some aloft while others stayed below, the team could compare two paths through time, one in motion and one at rest. The aeroplanes circled the globe, engines humming through long hours of flight. Aboard them, the clocks ticked onward, faithful and unhurried. All the while, identical clocks waited on the ground, keeping their own steady count of the passing seconds. When the travelers returned, the moment of truth arrived. The flown clocks no longer agreed with those left behind. They disagreed by tiny fractions of a second, almost nothing at all, yet unmistakably there. Motion had nudged the hands of time apart. And the size of that difference was no surprise. It matched what relativity had predicted, precisely as the theory foretold. A handful of clocks aboard ordinary planes had measured the bending of time, turning a strange idea into something gently, undeniably real. Far above the clouds, the International Space Station glides around our world. Inside it, astronauts float through their days, circling the planet again and again. They move quickly, far faster than anyone walking the ground below, and because of that speed, time treats them a little differently. Their swift orbit means their clocks run slightly slow. So the astronauts age very slightly more slowly than the people far beneath them. It is a tender thought that those who journey fastest grow older a touch less quickly than the rest of us. Do not picture a great gulf opening between them and us. The effect is delicate, almost vanishingly small. Across a single orbit, it is nothing you could ever notice, a whisper of difference hidden within the ordinary hours of a working day. Yet even small things gather, given time enough, over a long mission spent circling the Earth. The difference slowly adds up. Still, it amounts only to a small fraction of a second, a quiet keepsake of all those swift and silent miles. Imagine returning from space carrying that tiny, invisible gift. You would be younger than you otherwise would have been by the faintest sliver of time. It is a soft reminder that motion shapes our hours, even high above the sleeping world. Now let your mind wander outward, past the station and the stars nearby. Imagine a ship built to travel close to the speed of light, faster than anything we have ever made. Aboard it, a small crew sets out into the deep, leaving the familiar Earth behind them. For the crew, the voyage feels almost ordinary. Their clocks tick on, their meals come and go, and only a few years seem to pass. They live and sleep and dream as the great dark slips by, unaware of how strangely time is flowing for them. But back on Earth, the seconds march on at their own steady pace. While the travelers count a handful of years, the home world counts far more. Generations rise and pass. The planet turns through season upon season, century upon century of quiet change. So when the ship at last comes home, the crew steps into a future. Centuries may have passed across the world they left, while only a few years passed for them. They have leapt across time, not by magic, but by the simple grace of speed. And this is no mere fancy spun for comfort. It is real, allowed travel into the future, permitted by the laws that govern our cosmos. A fast enough ship truly could carry its crew ahead through the ages into a world long grown beyond their own. Here is a thought to hold gently as you rest. You are always traveling into the future already, every single moment of your life. With each breath, each heartbeat, you move steadily forward through time, carried onward whether you notice the passage or not. This is the quiet truth beneath all the wonders we have wandered through. Time travel into the future is not some far-off dream. It is the ordinary motion of every living thing, the slow and certain journey we all share, second by gentle second. What relativity adds is only a matter of pace. It offers ways to speed that journey up, to reach tomorrow a little sooner than the clocks around you. Move fast enough, and you arrive in the future ahead of those you left behind. So the strangeness softens into something almost familiar. The traveler on the starship and the sleeper in their bed are doing the same thing, moving toward what comes next. One simply hurries, while the other goes at the easy pace of an ordinary night. Let that ease your mind as the hour grows late. You need no ship, no great velocity to be a traveler in time. You are already sailing toward tomorrow, borne forward on the steady tide that carries all things gently onward. Think back now over all that we have gathered together, the muons falling softly from the sky, the atomic clocks aboard their circling planes, the astronauts aging a hair more slowly far overhead. Each one tells the same calm and remarkable story. In every case, the lesson holds true and unwavering. Motion slows the ticking of a clock by amounts both tiny and vast, from particles to people to imagined ships among the stars. The same gentle rule shapes the flow of every passing hour. There is a deep comfort hidden in that unity. The universe is not capricious or unkind in how it keeps its time. It follows patterns we can measure, predict, and trust, the same patterns whether we look up close or out across the void. So the cosmos holds not one clock, but countless many. Each moving thing keeps its own faithful count, its own private rhythm of seconds and years, and all of them obey the same quiet law, woven through the depths of space and time alike. Rest in the knowledge that this strangeness is also order. Time bends, yet it bends by rules, steady and dependable as the turning sky. The universe is stranger than we once believed, and far more beautiful and gentler than it ever needed to be. As this part of our journey draws toward its close, let the wonder linger a while. We have seen that time is not a fixed and rigid thing. It stretches with speed, it slows with motion, and it has been measured doing so over and over again. Travel into the future is not a fable after all. It is real, woven into the laws that hold the stars in place. Whether by a racing ship or the simple passing of a night, every one of us is carried ever forward through the years. And yet, for all its strangeness, time remains a gentle companion. It does not rush you here in the warmth of your bed. It lets you rest, lets you breathe, lets the slow hours hold you, while the wider cosmos keeps its many clocks. So release the day, and all its weight into the keeping of the night. The future is already coming to meet you, as it always has, with no effort needed on your part but to rest and let it arrive. You are a traveler in time, and the journey asks nothing of you now. Let your thoughts grow still, let your breathing slow and drift toward the tomorrow that waits so calmly ahead. Sleep gently, traveler, and trust the quiet tide of time. Here is another soft pause, a clearing in the long night. You need not hold any of the wonder we have wandered through. Let it loosen on its own and keep only the calm it leaves behind. The stars overhead keep their ancient places, faithful and unmoving, watching over your rest as they have watched over every sleeper before you. There is deep comfort in their steadiness. Let your breath fall into their slow rhythm, even and unforced. There is nowhere else to be tonight but here, beneath a sky that has always been kind. Imagine two twins born beneath the same sky, sharing the same first breath of air. One will stay at home on the earth we know, the other will leave for the stars. From that single parting, a strange and beautiful puzzle about time itself begins to unfold. This is the most famous illustration of time dilation, the tale we call the twin paradox. It asks something that sounds impossible at first. Can two people who began life together truly end up at different ages? Let the question settle over you, and we will follow it gently. Picture the first twins staying behind on Earth, walking familiar streets, watching familiar seasons turn. Their days pass in the ordinary way, sunrise after sunrise. Nothing about their life seems unusual to them, and yet far away, a different kind of time is steadily being lived. The second twin boards a ship built to fly near the speed of light. The engines hum, the home world shrinks behind them, and the great dark opens ahead. They will travel outward, then turn, then journey home again. This simple voyage holds the whole mystery. Hold both of these lives in your mind at once, like two candles in separate windows. One flame stays put, the other races among the stars and returns. The wonder is not that they part, but what they discover when they finally stand face to face once more. Here is the heart of it, the fact that makes the story unforgettable. When the traveling twin comes home, they are younger than the twin who stayed behind. Less time has passed for the one who moved through space so swiftly. The clock of the voyage ran differently. Let that idea rest with you for a moment. Two siblings, one origin, and now one face carries fewer years than the other. The stay-at-home twin may have silver in their hair. The traveler steps off the ship still closer to the youth they shared at parting. It is not illusion, and it is not a trick of measurement. The difference is woven into the fabric of their lives. Each twin felt their own time pass at the usual comfortable pace. Neither sensed anything strange. Only on reunion does the gap between them appear. Think of time as a river that does not flow at one fixed rate for everyone. The faster you move through space, the more slowly your moments unfold against another's. The traveler simply rode that current. They returned having spent fewer hours than the world they left. So the reunion is tender and uncanny at once. The one who went away has aged less than the one who remained. This is the answer the paradox is famous for. And now, drifting deeper, we can ask the natural question, how can this possibly be fair? The reason this tale is called a paradox lies in how motion looks from each side. At first glance, movement seems perfectly symmetric, a mirror held between the twins. Each could reasonably claim to be the one standing still while the other slipped away. So who is right? From the deck of the ship, the traveler might say the earth is the thing receding. The home twin watches the vessel shrink and feels themselves to be the steady point. Both seem to have an equal claim. Both seem to see the other as the mover. If that symmetry held all the way through, we would face a contradiction. Each twin would expect the other to be the younger one. They cannot both be right when they meet again. The puzzle is real, and it deserves a careful, unhurried look beneath the surface. So the question becomes a kind of riddle whispered between the stars. If motion is relative, if either could be called the one in motion, then how does nature decide? How does the universe choose which twin actually aged less? Something must break the perfect mirror between them. Let the tension hold for just a little while, the way a held breath waits for release. The appearance of symmetry is the trap. Underneath it, the two journeys are not the same at all. In the next chapter, we will find the difference that settles everything. Here is the resolution, simple once you see it. The situation is not truly symmetric because the two journeys are genuinely different. One twin turns around out among the stars, the other never does. That single fact tips the balance and decides who ages less in the end. The traveling twin must slow as they reach the far point of the voyage. Then they speed up again to begin the long way home. They feel that change, that great turning, in a way the home twin never experiences. Their path through the journey bends and shifts. The stay-at-home twin, by contrast, simply stays, no turning, no slowing, no sudden push toward home. Their motion through the whole story is smooth and unbroken. This asymmetry hidden beneath the mirror is what the paradox was concealing from us all along. So the mirror cracks, and the contradiction dissolves like mist at dawn. The twins are not interchangeable after all. One took a journey with a turning in it. The other held a single steady place. That difference in their paths is what settles which twin grew older. It is a calming kind of answer, the sort that lets the mind rest. There was never a true paradox, only an appearance of one. The voyage itself, with its outward rush and its homeward return, breaks the symmetry, and so nature knows exactly which face to aid. Now consider what the traveler has truly done by coming home. They have arrived in a future where their sibling has grown older than themselves. This is forward time travel, not in theory, but made personal. It is written plainly into the lines of two familiar faces. There are no strange machines required for this kind of journey forward. The travelers simply moved and turned and returned. In doing so, they leapt ahead, stepping into days their younger pace let them reach sooner. The future met them gently, and the family had changed. Picture the meeting at the end of the long voyage. The one who stayed has lived more seasons, gathered more years, carried more time. The one who traveled sees that future in a beloved face. The reunion itself becomes a soft, living portrait of forward time travel. It is forward time travel of the tenderest kind, measured not in clocks alone, but in kinship. Two people who began together now stand a little apart in time. The traveler has touched tomorrow. The home twins simply waited there, having lived each day toward that moment. So the famous paradox resolves into something quietly moving. Time travel forward is real, and here it wears a human shape. It is not cold physics on a page. It is two siblings, one slightly younger, meeting again across a gap that the stars themselves opened between them. You may wonder whether any of this has truly been seen. No human twins have done this with actual starships. That is certainly true, and yet the effect itself is entirely real. It has been confirmed again and again using clocks of remarkable, exquisite precision. Scientists do not need siblings in spaceships to witness time dilation at work. Careful instruments, the most accurate clocks ever built, reveal the difference directly. When one clock moves and another stays, their readings part by tiny, measurable amounts. The universe keeps its promise faithfully. So the twin paradox is far more than a charming thought experiment. It rests on something measured, tested, and trusted by careful minds. The story uses twins to make it vivid, but precise clocks make it certain. Imagination and evidence here walk gently hand in hand. Let that reassure you as you settle deeper into rest. This is not a fragile guess about how things might be. It is a confirmed feature of our world, quietly true whether or not we watch. Time really does bend with motion, and we have learned to see it. The clocks tell us the same tale the twins would, only in numbers rather than faces. Movement through space changes the passage of time by amounts we can record. The marvel is that reality agrees so precisely with the dream. The wonder and the measurement match. Perhaps you're thinking that you have traveled and never felt younger for it. There is a calm reason for that. At ordinary speeds, the gap in time is simply far too small to notice. The difference exists, yet it hides below anything our senses could ever catch. When you walk or ride or even fly across an ocean, you do move through space. Time dilation is present in all of it faithfully, but your speed is so modest compared with light that the effect shrinks to a whisper, a number too tiny to feel or see. This is why daily life feels so steady and shared. Friends who travel and friends who stay home age together, hour for hour. The clocks of our ordinary world stay close enough to seem identical. The grand effect waits, real but resting, for far greater speeds to wake it. So there is no need to suppose that a long trip costs you any years. At human speeds, the change is vanishingly slight, far beneath notice. The twin paradox needs the rush of light to become visible. Gentle motion leaves the difference sleeping, hidden in the smallest decimals. Let this be a soothing thought beneath the blankets tonight. The strangeness of time does not disturb your everyday calm. It hides itself with great courtesy until speeds grow immense. Until then, you and those you love share time as evenly as you always believed you did. One last gentle idea before we move onward through the night. The size of the difference depends on the voyage itself. The faster and the longer the journey, the wider the gap in ages on return. A small trip changes little, a vast one changes a great deal. Imagine a traveler who goes only a short way at modest pace. They come home barely younger, the difference almost nothing. Now imagine a voyage near light speed, stretching across long years. That traveler returns with a far greater distance opened between their age and their siblings. So time dilation is not a fixed amount, but a sliding one. It grows with speed, and it grows with the length of the wandering. The twins set the scale by how far and how swiftly one of them roams. The cosmos answers each voyage with its own measure. Think of it as a dial turned by velocity and by distance together. Turn it a little, and the twins stay nearly matched in years. Turn it far toward light and across great spans, and the gap yawns wide. The journey decides exactly how separate the two lives become. And so the twin paradox closes, a lullaby of motion and time. Two siblings, one staying, one roaming among the stars, aging apart by the shape of a single trip. Let the image carry you down toward sleep, where you may roam as far as you please and return. Pause once more, and let the great calm cradle you. The universe moves forward without effort, and so, tonight, may you. Let it hold you loosely now, with nothing to grasp and nowhere to go. No effort is needed to belong here. You are carried by time the way the stars are carried, gently and without strain, part of the same slow and steady motion of all things. So let yourself settle, soft and unhurried, into the wide calm of the night. The next part of our journey can wait until your breathing has grown slow and deep. In 1915, Einstein extended his earlier ideas into the general theory of relativity. It describes gravity not as a simple pull, but as the bending of space-time by mass. Every star, every planet, every drifting world presses gently into the fabric that holds them, and that curve is what we feel as weight. Picture the cosmos as a vast yielding sheet. Where mass gathers, the sheet sinks, and the dent it makes is gravity itself. Light and planets simply follow the hollow, tracing the shape that matter has carved. Let that image settle over you, unhurried as the night deepens around your resting mind. From this single idea came a prediction that still astonishes. Gravity does not only shape the paths of falling things, it reaches into time as well. The fabric that curves in space curves also in the hours, folding the two together into one seamless weave that the universe faithfully obeys. The deeper a clock rests within gravity, the more slowly it ticks. This is gravitational time dilation, the slow heartbeat of heavy places, stronger gravity, slower time. It is a rule written into the bones of the cosmos, and tonight it asks nothing of you but wonder. Nothing about this is hurried or harsh. It is simply how the world is built, layer beneath layer, depth beneath depth. As you breathe, imagine space-time as a calm sea that bends around every heavy thing within it. You are floating there too, held by the same gracious curve. Let us begin where the effect is gentlest. A clock at sea level runs very slightly slower than a clock high on a mountaintop. The difference is almost nothing, a whisper of time, yet it follows faithfully from how deeply each clock sits within the pull of the earth. The reason is depth. Down at the shore, a clock rests a little further into Earth's gravity than one lifted up among the peaks. Being deeper, it ticks more slowly. The mountain clock, raised toward thinner gravity, runs ahead, gaining the faintest sliver of time with every passing hour. How small is this difference? So small that no one would ever feel it in a single life. A heartbeat, a breath, a long, untroubled sleep all pass the same to you, whether you lie by the ocean or rest among the hills. The effect hides far below our senses. And yet it is real. This tiny lag between low places and high ones has been measured by careful instruments. The prediction left Einstein's mind and met the world, and the world agreed. Time truly does run differently a few steps up or down within our gravity. Think of it as the planet keeping countless clocks, each tuned to its own height. The valley clocks lag, the summit clocks lead, all by amounts too fine to notice. Let that quiet truth carry you downward into rest, as if you were sinking gently toward the slowest depths. Return for a moment to that high, clear summit. The air is thin, the gravity a touch weaker, and the clock there ticks a hair faster than its twin beside the sea. Two identical clocks, set side by side and then parted by height, slowly fall out of step. This is the strangeness softened to a human scale. We tend to think a second is a second everywhere, fixed and unchanging, yet height alone is enough to bend it, ever so slightly, proving that time is woven from the same fabric that gravity gathers and shapes. Imagine lifting a clock slowly from the beach toward the mountaintop. With every step upward, its ticking quickens by an unimaginably small degree. Lower it again, and it slows once more, settling back into the deeper, heavier time that waits down near the quiet surface of the ground. Nothing in the clock changes. No spring tires, no gear slips. The clock is faultless. It is time itself that flows at different rates, faster above and slower below. The instrument merely reports with honest hands the shape of the world it has been carried into. Hold this gentle picture as you rest. Tall places and low places, each keeping its own quiet rhythm, all of them true at once. There is no single correct hour, only many layered by depth. Let the layered time of the mountains lull your thoughts toward stillness. Now lift your gaze far above the highest peak to the satellites of the GPS navigation system. They orbit where Earth's gravity is weaker than it is for us on the ground. Being higher and freer of the pull, their onboard clocks run faster than the clocks down here below. These small machines circle the planet, threading the quiet dark above the atmosphere. From that height, the Earth's grip is loosened, and time for them runs a touch quicker than for anyone walking the surface. Each satellite carries a clock that steadily pulls ahead of ours, hour by hour. This is no mere curiosity. The whole system leans on these clocks agreeing with us precisely. Because the satellites tick faster, engineers must correct for the difference every single day, gently nudging their time back into line so the numbers they send remain trustworthy and true. Without that daily correction, the small differences would slowly grow until maps and directions no longer quite agreed. The soft, glowing dot that marks your place would slip from where you truly are, all because time runs faster in the heights above us. So each day, almost unnoticed, relativity is accounted for over our heads. The faster clocks of the satellites are tamed and matched to ours, and the maps stay honest. Let that steady, unseen care settle you, knowing the sky keeps its delicate time on your behalf. Consider how strange and ordinary this is at once. Every time a quiet voice guides you along a road, the relativity Einstein imagined is working overhead. Gravitational time dilation is not locked in dusty equations. It lives in the small machine that finds your way for you. The satellites and the ground keep separate hours, and the gap between them never rests. Up high the clocks gain, down low they lag. To bind the two together, careful minds measure the drift and answer it with corrections tuned exactly to the weakened gravity above. It is a kind of daily conversation between heaven and earth. The high clocks race ahead by a known amount, and engineers reply by holding them back, smoothing the difference so the whole network speaks with one steady, reliable voice across the turning face of the world. Let yourself marvel softly at the reach of a single idea, a theory of bent space-time born long ago now keeps your travels true. The same rule that slows clocks at the bottom of gravity lifts them in orbit, and we have learned to live with both. Breathe and let this knowledge rest lightly on you. High above, time runs faster. Down here it runs slower, and careful hands keep the two in tune. You need carry none of it. The work is done in the silence overhead while you sink toward sleep. Now journey in your mind alone toward the deepest gravity the cosmos holds, near a black hole where the pull grows immense beyond imagining. Time would slow to a crawl. The fabric bends so steeply there that the hours themselves seem to thicken and almost cease to move. Approach such a place and time stretches like honey. What feels to you like an ordinary hour spent close to that tremendous gravity could pass while years, even centuries, slip silently by for the distant universe. The deeper you fall, the wider this gulf of time becomes. This is the same rule you met at the shore, and the summit only carried to its extreme. There height shifted time by a whisper. Here the bending is so vast that whole lifetimes part ways, gentle on the mountain, overwhelming by the black hole, yet one single law throughout. Picture yourself hovering safely at a distance, watching the far stars. They would seem to hurry, wheeling and aging, while your own heart beats slow and even. The cosmos beyond would race through its long story, and you, held near the depths, would linger in a slower now. There is a strange peace in this thought. The heaviest place in the universe is also the most unhurried, where time pools and slows and nearly rests. Let that immense calm reach you here in your bed, and let your own breathing ease toward its deepest, slowest rhythm. So falling deep into gravity becomes another true doorway to the future. Not a trick of stories, but a path the laws of nature genuinely allow. Sink close enough to overwhelming gravity, linger there a while, and the universe ahead of you steadily ages while you do not. Imagine the return. You climb back out from the edge of such a place and rejoin the wider world, yet you would find it far older than when you left. The distant stars advanced, long ages folded into what felt to you like only a brief and quiet stay. It is travel forward in time without any hurry, without any machine of gears and dials. Gravity alone does the work. To leap ahead, you would simply rest near the depths and let the lighter universe run on, returning to a tomorrow that arrived while you waited. There is a quiet solitude in the idea, and a wonder too. The deep gives you the future at the cost of the present you knew. Those far away would live their whole long lives, while for you only hours had turned beside that great and silent weight. You need not travel anywhere to feel its grace tonight. Simply know that the cosmos is built so that depth and time are bound, that to go down is, in a way, to go forward. Let the thought carry you onward gently into the future of your own coming morning. Let us gather these wonders as the chapter closes. Gravity is the bending of space-time, and that bending touches time itself, slowing every clock that rests within its depths. From shore to summit to orbit to the black hole, one calm law runs through them all. Remember the shore clock lagging behind the mountain clock by a whisper. Remember the satellites racing ahead and being gently corrected each day. Remember the black hole where an hour could hold centuries. Each is the same truth spoken at a different depth in a different voice. Time, it turns out, is not a single river flowing at one speed for all. It pools and slows in heavy places and quickens where gravity thins. You have lived your whole life inside this layered time without once needing to notice its quiet, faithful work. And so the deepest places keep the slowest hours, as if the universe saves its stillness for the heart of its heaviest things. Sinking into gravity is sinking into a slower now, a more unhurried flow of moments, a calmer and more spacious kind of time. Let yourself sink that way now, downward into rest, where your own hours may run as slow and easy as you wish. The cosmos holds its gentle clocks for you. You need keep none of them. Breathe out, settle deep, and let the slowest, kindest hour carry you to sleep. Rest again beneath this quiet sky. The hour is late and the dark is kind, and there is nothing left undone that the morning cannot keep. Let the stillness widen around you. Above you, the vast cosmos moves without strain, slow and sure, needing no help and no watching. You may set down every task and simply be here, breathing at ease. Feel the gentle weight of your own resting body, and let it anchor you while your mind floats free among the far and quiet stars. Travel into the past is far harder than travel into the future, yet the equations of general relativity permit some strange possibilities, at least on paper. Tonight we wander down those corridors where mathematics opens doorways no one has ever walked through, and the universe seems to hold its breath. Picture a tunnel that does not run through earth or rock, but through the very fabric of space and time itself. Its walls are woven from geometry. Its far end might open beside a star you will never otherwise reach, across a gulf that light would take an age to cross. In 1935, Einstein and Nathan Rosen described such a passage. Later it became known as a wormhole or an Einstein-Rosen bridge. On paper it is a tunnel through space-time, joining two distant points, as though the cosmos had been folded until two faraway places nearly touched along a hidden seam. Imagine the universe as a vast sheet, and 2 points pressed close by that folding. A wormhole would be the slender thread connecting them straight through the gap. Instead of the long journey across the surface, you would slip through the shortcut, emerging somewhere remote in a single quiet step. This is geometry dreaming aloud, a possibility living first in the equations rather than the sky. No such tunnel has ever been found. Still, let the picture settle over you like a warm blanket, a doorway sketched in light, waiting in the mathematics for someone to test whether it could be real. A wormhole in these descriptions has 2 mouths and a throat between them. Each mouth opens into ordinary space, perhaps separated by unimaginable distance. The throat is the tunnel itself, a region where the familiar rules of nearness and farness gently come undone and shortcuts begin to seem possible. Think of 2 doorways standing in different rooms of an enormous house. Step into one and you step out the other, though miles of corridor lie between them. The wormhole would do the same across the galaxy, linking 2 mouths through a throat that ignores the long way around entirely. What lives inside the throat is hard to imagine, since nothing in our experience behaves quite like it. Distance loses its ordinary meaning there. 2 places that seem hopelessly far apart in the sky might be joined by only a short walk through the hidden interior of spacetime. The Einstein-Rosen bridge of 1935 was, in its first form, no friendly passage. It would pinch shut too fast for anything to pass, a tunnel that closes the instant it opens. The simplest wormhole, in other words, refuses to let a traveler through its narrow throat. So the early picture offered a tantalizing shape with a locked door. A tunnel was there in the equations, yet sealed against any crossing. The question that lingered quietly was whether one might ever be coaxed to stay open, held wide enough for someone to step inside. In 1988, the physicist Kip Thorne and his colleagues returned to this idea with a bolder question. Could a wormhole be made traversable, held open long enough to cross from one mouth to the other? Their work explored what such a stable tunnel would actually require of the universe. To keep a throat from pinching closed, you would need something to brace it apart, like beams holding up a wide doorway. But ordinary matter will not serve. The thing that could prop the tunnel open must be far stranger than anything we handle in daily life. Thorne and his colleagues found that you would need exotic matter, a substance carrying negative energy. Such matter would push outward where ordinary stuff pulls inward, holding the throat wide against its own urge to collapse. It is the scaffolding that might let a traveler pass safely through. Here lies the great obstacle. Exotic matter with negative energy may not exist in anywhere near the amounts required. Tiny hints of such effects appear in delicate experiments, but bracing a tunnel across space-time would demand staggeringly more than nature seems willing so far to provide. So the door can be imagined open, yet the hinges call for a material we cannot gather. The mathematics is generous, and the cosmos, for now, withholds the means. Let that tension rest gently in your thoughts, a tunnel waiting on an ingredient that may forever stay out of reach. Then comes the truly startling turn. In 1988, the same work showed that in principle a traversable wormhole could link not only two places but two different times. The tunnel might become a doorway to the past, its two mouths separated not by distance alone but by years. The idea begins with motion and time. If one mouth of the wormhole were moved swiftly, while the other stayed at rest, the strange clockwork of relativity could let the two ends fall out of step. One mouth would age differently from the other, opening a gap in time. Step into the younger mouth. The reasoning goes, and you might emerge from the older one at an earlier moment than you left. The tunnel would thread not only across the room of space, but backward along the river of time into an afternoon already gone. It is a delicate, astonishing notion, and worth saying plainly. This remains deeply hypothetical, a structure standing only in the equations and the imagination. No wormhole, time-linking or otherwise, has ever been observed, built, or shown to be possible with the materials our universe appears to offer. Still, the picture is wondrous to hold at the edge of sleep. A tunnel whose far end opens yesterday, lit by a sun that has already set. Let it shimmer there, a doorway sketched in pure possibility, asking nothing of you but a calm and curious mind. Wormholes are not the only doorway the equations allow. In 1949, the mathematician Kurt Gödel found a different route into the past, hidden inside the geometry of an entire cosmos. His was not a tunnel, but a whole universe, shaped so that time itself could curve around. Gödel found a solution to Einstein's equations describing a slowly rotating universe. In such a world, the whole of space turns gently, like a vast wheel with no rim, carrying everything within it through a stately, almost imperceptible revolution that subtly reshapes the meaning of past and future. In that turning cosmos, something remarkable becomes possible. One could, in theory, follow a closed loop in time, traveling outward and around until arriving back in the past. The path would curve through space and through the years, returning the traveler to a moment already lived. A closed loop in time is a strange shape to picture. Imagine a journey that bends so far it meets its own beginning, a circle drawn not on paper but through the history of the world, where setting out and coming home become, somehow, the very same event. Our universe does not appear to rotate in the way Gödel imagined, so his world stays a possibility on the page. Even so, it revealed something profound. Einstein's own equations did not forbid time from looping, and that quiet discovery has lingered in physics ever since. Gödel's rotating cosmos was only one way to bend time into a circle. Other proposals reach for stranger objects scattered through the imagined sky. Among the most curious are cosmic strings, thread-like flaws in spacetime, finer than an atom yet stretching across staggering reaches of the heavens. A cosmic string would be a thin line of immense tension and energy, a crease left in the fabric of the cosmos. Picture a thread drawn taut from one end of the sky to the other, so dense that the space around it is subtly warped and pinched. Some proposals describe infinitely long spinning cosmic strings. When two such threads sweep past one another, the warped space around them can, in theory, allow a closed loop in time. A traveler circling that strange pair might trace a path that ends before it began. The picture has a stark, austere beauty. Two luminous threads spinning through the void, and between them a hidden circuit through the years. It reads almost like a myth told in the language of geometry, a loom on which time itself could be woven into a ring. Yet honesty asks for a steady voice. These spinning strings have never been seen, and may not exist anywhere in the universe. They are shapes the equations tolerate, not objects we have found, glimmering only in the careful arithmetic of those who study the deep structure of space. It is worth pausing to feel the sheer scale of these ideas. Every one of them, the wormholes, the turning universe, the spinning strings, remains deeply hypothetical, far beyond anything humanity could ever build. They are thought experiments, not blueprints, living in mathematics rather than in metal and stone. Consider what a traversable wormhole would ask of us. Exotic matter with negative energy, in quantities that may not exist, arranged with a precision no engineer commands. We could not begin such a project, nor finish it, nor even be certain the ingredients are anywhere to be found. The turning universe of Gödel asks for something we cannot supply at all, an entire cosmos rotating just so. We do not get to choose the shape of the universe we inhabit, and ours, by every measure, does not spin in the manner his vision would require. Even the cosmic strings, were they real, would be objects of unimaginable scale and tension, sweeping past each other across the gulfs between stars. To use them, one would have to journey among such threads and circle them precisely, a feat beyond any power we can presently conceive. So these doorways stay firmly in the realm of speculation, and that is no failing. They mark the outer boundary of what the equations permit, the far shore of the possible. To know that the mathematics does not forbid them is itself a strange and lovely gift. What are we to make of these tunnels and loops as the night deepens? They are honest products of our finest theory of gravity taken to its furthest edges. General relativity, asked whether the past can be revisited, answers not with a flat no, but with a thoughtful perhaps. That perhaps is precious, even if no traveler ever uses it. It tells us the universe is subtler than our intuitions, that space and time can fold and turn in ways our daily lives never hint at. The equations hold doors we may never open, yet there they are. Notice, too, the great obstacles standing guard. negative energy we cannot muster, a cosmos that will not rotate to order, strings that may never have formed. Nature seems to leave the doors ajar in theory while quietly withholding every key that would let us walk through them. Perhaps that is its own kind of mercy, a tidy arrangement that keeps cause before effect and yesterday safely behind us. The mathematics dreams of doorways to the past, while the world we wake in keeps its mornings and evenings in their familiar comforting order. So let these speculative tunnels fade now into the hush of the late hour, wormholes braced by impossible matter, a slowly turning sky, threads of light spinning loops through the years. Hold them lightly as you settle, and let your thoughts ease at last toward sleep. One last pause before the journey's final stretch. Let everything grow soft and slow. Time has flowed for billions of years. It can surely carry you a little while longer as you rest. There is nothing but calm in all that space overhead. It is only the cosmos, vast and calm and ancient, moving forward with great tenderness and carrying you along among the stars. Let the quiet carry you onward, closer to sleep with every slow breath. Whatever remains of the night will unfold gently and ask nothing of you but to rest. To move into the past is to invite a handful of curious puzzles. They are not dangers but questions, the sort that turn slowly in the mind near sleep. Tonight you can hold them lightly, like smooth stones warmed in the palm, and simply wonder. Picture a traveler stepping backward along the years into rooms that have already happened. The moment they arrive, certain riddles begin to stir, asking how a single life could ever loop back and touch its own beginning. These are the famous paradoxes of time. None of these puzzles need solving before you rest. They belong to thought alone, to chalkboards and long evenings of friendly argument. Let them hover at the edge of awareness, soft as distant stars, while your breathing settles into its slow and even rhythm. Physicists have given these riddles names and shapes, turning confusion into something almost beautiful. Each one is a small doorway, opening onto questions about cause-effect and the strange shape of a looping life. We will walk through them one calm step after another. So let the worry drain away before we begin. Nothing here can reach you or unsettle the night. These are gentle riddles to admire from a distance, the way you might admire a constellation you will never need to climb. Breathe and let us wander. The most famous riddle is called the grandfather paradox, and it is easier to feel than to solve. Imagine traveling far into the past and, by some accident, keeping your own grandparents from ever meeting. A small change, and yet it reaches everything. Follow the thread of that idea, gently, without alarm. If those two people never meet, then one of your parents is never born, and so neither are you. The very traveler who made the journey would simply have no way to exist. Here the loop tightens into its lovely knot. If you were never born, you could not have traveled back, which means the meeting was never prevented, which means perhaps you were born after all. The story chases its own tail in slow circles. Notice that nothing about this needs to frighten you. It is a riddle of logic, not a warning about the world, and no one has ever stood in such a room. You are only watching the idea fold over itself like a ribbon. Let the paradox rest here for a while, unsolved and unhurried. The grandparents in the story are safe. The traveler is safe, and so are you, wrapped in the ordinary present. We will see how thinkers have tried to ease this puzzle. A second riddle is quieter and stranger in its own way. It is called the bootstrap paradox, or a causal loop, and it asks where certain things truly come from. Settle in and let the question circle softly around you. Imagine a single object or a small piece of information carried from the future back into the past. There it waits through the years until, in time, it is carried forward again, only to be sent back once more. Around and around it goes. Trace that circle as far as you like, and you will never find a starting point. The object exists plainly, yet no one ever made it, wrote it, or first imagined it. It simply loops handed onward, forever, with no true origin. There is a strange comfort in the shape of it, a thing complete in itself, needing no maker. Like a melody that seems to have always existed, it folds back into its own beginning, endless and self-contained. The mind turns it over slowly. You need not resolve where the loop began before you sleep. It is enough to picture it, smooth and closed, turning in the dark like a ring of faint light. Let that quiet circle carry your thoughts gently around and down. For every riddle, thoughtful people have offered gentle answers, and the first is especially calming. It is named the Novikov self-consistency principle after the physicist Igor Novikov, and it rests on one simple, reassuring idea: listen as it unfolds. The principle suggests that the universe will not allow a contradiction to occur, ever, under any circumstance. Whatever a traveler did in the past, it could only be something that had always happened, woven seamlessly into the history we already know. Under this view, you could not prevent your grandparents from meeting, no matter how you tried. Some quiet turn of events would always intervene, and your actions would simply become part of the story that led to your own birth. Feel how this idea smooths the earlier knot completely. There is no danger of erasing yourself, because the past is whole and consistent already, and any visit was always a thread in its weave. Nothing can tear, everything holds together. So Novikov offers a tidy sort of peace. The timeline cannot break, cannot fork, cannot fall into contradiction, because reality politely refuses. Let that thought rest in you, every corner of the puzzle tucked away, the whole picture calm and unbroken. A second resolution comes from a wholly different picture, the many worlds idea. It answers the same riddles, yet it does so by opening reality outward rather than holding it shut. Let your imagination widen a little as we consider it. In this view, changing the past would not erase the history you remember. Instead, your action would create a new branch of reality, a parallel path splitting away like a river dividing around a stone. Both courses continue, each fully real. So the timeline you came from remains untouched, exactly as it was. You do not unravel your own past. You simply set a fresh branch growing beside it, while the old one flows on, undisturbed, carrying every memory safely along. Picture countless such branches spreading like the limbs of an ancient tree. Each choice, each visit, each small change sends another gentle shoot outward, and none erases the rest. The whole quiet forest of possibility grows wider with every step. It is restful to imagine so many parallel paths, all of them safe. Whatever a traveler does, nothing precious is lost. It only multiplies into new directions. Let that wide branching calm spread through you as your thoughts begin to slow. Now we hold the two resolutions side by side, like a pair of lamps. One says the past is single and unbreakable, the other says it gently splits into many. Both dissolve the paradox, each in its own graceful way. Under Novikov, the universe guards a single consistent story, refusing every contradiction before it can arise. Under many worlds, contradictions never form because each change blooms into its own branch, different roads yet both arrive at a place of ease. It is a small marvel that one puzzle can have two such different cures. The grandfather riddle simply melts, whether reality holds firm as one thread or opens into many. The knot loosens either way, and the worry falls quiet. You do not have to choose between them tonight or ever. They are ideas to admire, not rules to obey, and both leave the traveler unharmed and the cosmos serene. Hold one in each hand, weightless, and feel how light they are. Let the two answers rest together in your mind without contest. Whether the timeline is one or many, the lesson is the same gentle one. Nothing breaks, no one is lost, and the riddle was only ever a riddle. Breathe and ease lower. These puzzles do more than amuse the curious. They hint at something deeper. For many physicists, the very trouble of the paradoxes is a clue that travel into the past, however neat on paper, may be quietly forbidden in practice. The reasoning is calm and almost humble. If a journey backward would tangle cause and effect into knots this stubborn, perhaps nature has its own way of closing that door before anyone can step through. The universe may simply prefer order. So the equations might permit such a voyage while reality declines to allow it. What looks possible in the cool language of mathematics could still be ruled out by some deeper law we have not yet fully glimpsed. It is a gentle suspicion. This is not a verdict, only a leaning, a shared sense among many thoughtful minds. The question stays open, unhurried, the way good questions do. No alarm rides along with it, just the slow pleasure of wondering where the limits lie. Let that uncertainty feel restful rather than unfinished. It is enough to know that wiser heads still turn the problem over, and that the night asks nothing of you but rest. The door may stay shut, and all is well. For now, every one of these puzzles remains a thought experiment, nothing more. No one has ever traveled into the past, so no one has ever truly faced the grandfather riddle or held a looping object in their hands. They live only in imagination. They are gentle riddles made for turning over in a restful mind. You can carry them the way you carry a half-remembered song, light and pleasant, asking nothing, troubling nothing, simply keeping the imagination warm as the night deepens around you. Remember the shapes we wandered through, each one harmless. The knot of grandparents, the loop with no beginning, the single unbreakable story, the softly branching worlds, and the open question of whether the door stays closed forever, a small museum of wonders. None of them was ever a problem you needed to solve. They were puzzles to admire by lamplight, riddles to set down gently when sleep drew near. You may leave them all on the shelf now exactly where they belong, undisturbed. So let the paradoxes fade into the calm, like stars dimming toward morning. The traveler is safe, the timeline holds, the worlds branch on without you, and you are here breathing slowly, ready for rest. Let go and let the quiet carry you down. Picture all of time laid out at once, past and future together, in a single unchanging four-dimensional whole, because observers moving differently disagree about what counts as now. Many physicists imagine the universe this way. They call it the block universe, or eternalism, a vast and motionless landscape of moments. In this picture, every moment simply exists, resting in its own place. The morning you were born and the morning yet to come are equally real, equally present within the block. Nothing arrives and nothing departs. The whole of time is already here, complete. Where then is the flow we feel so surely, the steady passage from one instant to the next? It may be a feature of how our minds experience the world rather than a feature of time itself. The river of now might run only through us. Consider this very moment, the one in which you are resting in the block universe. It does not pass away when the next begins. It stays fixed forever in the great structure, as real 1,000 years from now as it is tonight. There is a strange comfort in such a thought. If every moment endures, then nothing truly is lost, only set in its place within the whole. The hours you love remain, held in the calm architecture of space-time, while you breathe and let the idea settle around you. Across the whole of physics runs a single limit that nothing carrying mass can ever reach: the speed of light. It is not merely difficult to attain, but truly unreachable, a boundary woven into the fabric of relativity. Everything time travel could ever be is shaped by this rule. Imagine pushing an object faster and faster through the dark between the stars. The faster it goes, the more energy it takes to speed it up further. That cost does not simply rise, it climbs without limit as the object nears light speed. So the goal can never quite be reached, no matter how vast the push behind it. An endless amount of energy would be needed for that final step, and the universe offers no such thing. Mass forever falls just short of the line. Yet light itself crosses no such barrier, for it carries no mass at all. It always travels at exactly that speed, never faster and never slower, racing through emptiness at the one velocity nothing else can match. The limit is light's natural home. This universal speed limit shapes everything quietly, far beyond the reach of any engine. It sets the pace of cause and consequence of starlight and signal alike. Rest now within its certainty, knowing the cosmos keeps a steady and unbreakable measure. A curious link binds speed and time together, hidden in the equations of relativity. The closer a thing comes to light speed, the stranger time grows around it, and were that ultimate boundary ever crossed, the link would bend toward something almost unthinkable. If anything could somehow travel faster than light, relativity suggests it could, in effect, move backward through time. Such a traveler might arrive before it ever set out, reaching a destination earlier than the moment of departure. Cause and arrival would trade places. Some thinkers have imagined particles that always outrun light, hypothetical specks called tachyons. By their very nature, these would never slow to light speed or below, forever dwelling on the far side of the barrier. They live only in the mathematics for now. Yet none have ever been found despite careful searching across the years. Most physicists doubt that tachyons exist in our world, treating them as a curiosity rather than a discovery. The faster-than-light realm remains a country no instrument has ever touched. So the apparent impossibility of outrunning light is part of why reaching the past is so hard. The very speed that might open a door to yesterday seems forbidden to all that we know. Let that gentle barrier hold the past safely beyond our reach. One reason physicists guard the speed of light so carefully is a principle named causality. It is the simple rule that a cause must come before its effect, a thread running straight and unbroken through every event. The whole of physics leans upon it. Think of how plainly this order shows itself in ordinary things. A glass must be knocked before it falls. A word must be spoken before it is heard. Each effect waits its turn, arriving only after the cause that gave it birth. Now imagine a signal that could outrun light, or a journey reaching into the past. Such things could let an effect arrive before its cause, the falling glass preceding the touch that tipped it. The familiar sequence would come undone. This would tangle the orderly thread of cause and effect that the universe seems to hold dear. Events might loop back upon themselves, answers appearing before their questions, in a knot the mind can scarcely follow. The simple line of before and after would blur. Perhaps this is why nature keeps light's limits so faithfully, protecting the order we depend upon. Cause leads, effect follows, and the world stays sensible because of it. There is peace in that reliable procession, one moment giving rise to the next. Tales of time travel often imagine a machine of dials and levers humming in a quiet room. Someone steps inside and is carried back to rewrite the past at will, undoing old sorrows with a turn of a wheel. It is a lovely dream. Real physics is both humbler and stranger than those stories suppose. It does not hand us a wheel to spin, yet it opens doors the tales rarely dreamed of. The truth wears a plainer coat and hides deeper marvels beneath. It clearly allows travel into the future, a genuine and tested possibility. Through great speed or through the deep gravity near a massive body, time can slow for one traveler while it races ahead for others. Tomorrow can truly be reached early. Toward the past, it offers only the faintest hint, ringed about with heavy conditions. The equations whisper of possible doorways backward, but never plainly, never without demands so steep they may forbid the journey outright. That whisper stays barely audible. The easy rewriting of history that fills so many stories finds little support in the equations. We may sail forward freely, yet the past keeps its door nearly shut. Hold both truths gently, the open road ahead and the sealed gate behind. Whatever exotic possibilities the equations may hold, one form of time travel belongs to everyone alike. No machine is needed for it, no great speed and no deep gravity. It asks nothing of you but to be here, breathing, present in this hour. We are all moving into the future together, side by side, carried along on the same current. The pace is gentle and unhurried, the same for the resting and the running, the same for every living thing beneath the stars. None of us travels alone. It is the single voyage no one is left out of, the one passage shared by all that exists. Mountains and oceans make it, distant galaxies make it, and so do you, each moment slipping into the next without effort or fear. There is a quiet companionship in this, all things carried forward through time as one great company. The sleeping and the waking move at the same unbroken rhythm, bound together by the simple fact of going on. You are never apart from that procession. Tonight, you are making that journey too, simply by resting here and letting the hours pass. You need do nothing to travel through time. You are already doing it, perfectly, with every breath. Rest easy, fellow traveler, and let the future come to meet you. Imagine the past as a quiet house with a door that never quite opens, no matter how gently you lean against it. In 1992, the physicist Stephen Hawking gave a name to that locked feeling. He called it the chronology protection conjecture. The idea is tender in its way. Hawking suggested that the laws of physics may quietly conspire to keep time machines from ever forming. History, in this view, is protected from meddling, kept whole and undisturbed. Think of the universe as a careful keeper of its own story. It does not slam the door on the past so much as let it settle closed, the way a room grows still when evening comes and the lamps are lowered. You need not solve any of this tonight. It is enough to rest in the thought that the past, if Hawking was right, stays sealed and safe behind us. Nothing you have lived can be reached back into and rearranged. So let the notion settle over you like a quilt smoothed flat. A door that will not open is also a door through which no trouble can return. There is a strange comfort waiting inside that simple closing thought. Suppose for a moment that a loop of time began to form, curling back on itself like a ribbon finding its own tail. Hawking's reasoning suggests it would not survive the attempt. Something within it would rise up and undo the work. That something is the restless world of quantum effects. Inside any forming loop, these tiny fluctuations would build up uncontrollably, gathering strength like an echo that refuses to fade and instead grows louder with each return. Picture a whisper that doubles back and meets itself, then doubles again until the gentle sound becomes a roar too large for the room to hold. The loop, overwhelmed, would break before anyone could ever step through it. So the time machine destroys itself in the cradle, dissolved by its own runaway energy. It is undone before it can be used, closing the path the very instant the path tries to open. The universe tidies up after itself. There is an odd grace in this self-correction, like a held breath that releases on its own. You can let your shoulders lower as you imagine it, the loop unwinding back to nothing, the present left calmly intact. Beyond the deep mathematics, Hawking offered a clue so simple it could make you smile in the dark. We have never once met a visitor from the future. Not a single traveler has ever knocked upon our present. In 2009, he turned this absence into a quiet joke. He held a party meant only for time travelers, with fine glasses set out and chairs arranged for guests who might arrive from years not yet lived. The mischief lay in the timing. He sent out the invitations only afterward, once the party was already over, so that anyone with a working time machine would know exactly when and where to appear. And yet the chairs stayed empty. No guests arrived, no strangers from tomorrow filled the room, only the steady hush of a present that keeps its own company, The future, it seems, did not write back. Let that empty room reassure rather than sadden you. If no one comes back to visit us, then perhaps the past is truly settled, and each moment we live is ours alone, unvisited and entirely our own. Set the time machines aside now and ask a softer question. Why does time flow only forward, never back? Why can you remember last evening, yet never recall the details of next week? The deepest answer lives in a single word: entropy. It is the steady increase of disorder described long ago by the second law of thermodynamics, and it threads silently through everything that changes around us. Entropy tells a one-way story. The past was more ordered, more neatly arranged, while the future will be a little less so, a touch more scattered. That difference is small in each moment, yet endlessly faithful. From this gentle imbalance, time draws its direction. We even have a name for it, worn smooth with use, the arrow of time. It points always away from the ordered past and toward the open future. You are riding that arrow now, carried forward on it as you rest. There is nothing to do and nowhere to steer. The lean of time holds you, the way a slow current holds a leaf upon the water. Entropy can sound distant, but it lives in the smallest moments of your day. A drop of color falls into water and spreads outward, blooming into pale clouds, yet it never gathers itself back into a single bead. Consider a warm cup left upon the table through the evening. It cools toward the temperature of the room, giving its heat away to the air. It never, on its own, draws that warmth back and reheats. These are not failures of the world, but its deepest habit. Spilled things spread, warm things cool, ordered things loosen, and each of these everyday changes is entropy at work, gently pointing the way time runs. Notice how natural it feels, how unforced. No one has to push the drop outward or coax the cup to cool. The universe simply leans in one direction, and all these small motions follow without effort. You can feel yourself inside that same easy current. Like the cooling cup, your body settles toward rest, releasing the heat and hurry of the day, asking nothing of you but to let the slow change carry on. It may seem a loss that time runs only one way, that we cannot fold back and revisit a single afternoon, yet within that single direction lives a kindness, steady and sure, that is easy to overlook. Because time leans forward, each moment arrives fresh and unrepeated, then yields its place to the next without struggle. You are never asked to hold two moments at once, only to receive them one after another. Think of how restful that truly is. There is no need to guard the past against change, no need to brace for the future to rush in early. The order of things is settled, and you may simply rest within it. The arrow that forbids return is the same arrow that carries you onward into sleep. It is not a wall, but a gentle slope, inclined toward rest, asking only that you let yourself be carried down it. So loosen your hold on the wish to go back. The one direction time offers is enough, and more than enough. It moves you without effort of your own toward the deep quiet that is already waiting ahead. No one yet knows the final word on time, and its locked away past. The chronology protection conjecture remains a beautiful idea, not a closed case, and the universe keeps a few of its deepest answers to itself. But notice how little that uncertainty disturbs the peace of this moment. Whatever the final truth turns out to be, we sail steadily onward, one moment following the next, with no need to know the ending tonight. Perhaps the past is sealed by quantum effects, or perhaps sealed for some reason not yet found. Either way, the present holds you exactly as it does now, calm and complete, asking nothing further of your tired mind. There is a deep and simple peace in that single, certain direction. You do not have to understand it to be soothed by it, any more than a sleeper must understand the turning of the quiet stars overhead. Let the open questions stay open, untroubled, like distant lights you need not reach. The mystery will keep until morning, and longer, for now the only thing asked of you is to rest within the moving present. So here we arrive at the end of all this wondering about time. The past stays closed behind you, perhaps protected, certainly beyond reach. The future has not yet formed, only this gentle present remains, holding you now. You have followed time machines and loops, entropy and its steady arrow, all the way to this hushed and resting place. There is nothing left to chase, no door to try, no traveler to await. The thinking is done. Feel how the single direction of time asks nothing of you. It moves on its own, carrying the stars in their slow turning and your own breath in its easy rhythm, one moment and then the next, without any pushing. Whatever may be true of the locked away past, you are safe in the onward flow of now. Each moment sets you down softly into the one that follows, the way a slow tide lays a small boat closer to shore. So let yourself be carried fully and without worry into the deep stillness ahead. Time leans toward your rest, sure and kind, and there is a quiet peace in that one certain direction. Sleep now. The present has you. Our slow journey through time is over now, and you have done the only thing it asked of you, which was to rest. There is nothing to keep and no fact to carry into the light. The whole quiet voyage was only ever a soft place to set yourself down. If you are still awake, let there be no worry in it. Remain here in the warm hush a while longer, breathing slow, carried forward by the same gentle current that moves the stars. Sleep arrives the way time does, not when forced, but when everything grows still enough to allow it. And if you are drifting now at the soft edge of sleep, let yourself go completely. Time will keep its steady forward flow, the stars will keep their slow turning, and morning will arrive in its own unhurried hour, exactly when it should. Thank you for spending this night with us, here at the Circadian Institute, sailing the quiet river of time. Sleep now and sleep deeply. The whole calm universe moves forward beside you, and you are perfectly at home within it. Good night, and the deepest of good rests to you.